Hey, good morning or afternoon. It's Mr. Walker back at you. Today we're doing composite figures. Now, what's a composite figure? It's a bunch of shapes put together. Here in the figure in front of you, you got a triangle, a rectangle, and a semicircle. In order to find the area, you have to find the area of each piece and add them all together. Now, here's a hint. Whenever it says find the area, we're only concerned with what's shaded in. There is a difference, and I'll get to you in number 2. But for now, we're doing number 1. We're going to start with a triangle. So in order to start with a triangle here, okay, I'm going to say area of triangle. And here's a pro tip. As you're going along, label which area is which, so that way you're not losing track. To find the area of the triangle, we need to take 1/2 times the base times the height. This is nothing new. However, we actually don't know what the base or the height is. So I'm going to put the height right here. I'm going to put the base in blue. We can find the height with what we've got right now. So I'm going to say triangle height. We can find it with what we've got. Take the 7.8, which is the distance from here to the semicircle, and take 3 feet away from it. So 7.8 minus 3, that gets you 4.8. And go ahead and label it 2. So this guy is 4.8 feet. So that's 1/2 times 4.8 times something else. We don't know what that something else is yet. So we need to find it. We can find it. We do have enough information now. Because what kind of triangle do we have? We got a right triangle, which means I can use the Pythagorean theorem. Whoops. If I could spell correctly, that'd be cool. Pythagorean, there we go. Pythagorean theorem, and in parentheses, I'll put triangle base. Because we're using that to find the triangle base. Remember, that's a squared plus b squared equals c squared. I'm going to call this guy b for base. So that means a is my 4.8. So 4.8 squared plus b squared equals c squared. C is our hypotenuse, that is 10.2 squared. This is where you get your calculator and start squaring these. 4.8 squared is 23.04 plus b squared equals 104.04. Now we've solved stuff like this in the past before, so I'm going to breeze right through it. So subtract 23.04. I get b squared equals, what did I get, 81. Take the square root of each side. B is 9. Specifically, it is 9. Uh-oh, it froze on me. There we go. 9 feet. So right up here, I'm going to plug in that same 9 and multiply all of this together. 1/2 times 4.8 times 9. That gets you 21.6 feet squared, because we're talking about area. So that's the area of the triangle. Now we got to find the area of the rectangle. That's the easiest one of the 3 that we're looking for. So area of rectangle. That's just base times height, which is 3 times 9, which is 27 feet squared. There's nothing to that one. Now I gotta find the area of the semicircle. So let's do purple. So we got area of specifically the semicircle. Now, if you recall, the formula for the area for a circle is pi r squared. A semicircle is half of that. So we're going to divide this formula by 2 in order to find the semicircle. So we take pi times our radius, We don't know the radius, but we know the diameter. It's 9. And that comes from part of the rectangle. Right here, that was 9. So take 9, divide it in half. That gets you the radius. In this case, it's 4.5. So take 4.5 squared. That's 20.25. 20.25. And we still have pi and divide it by 2. Now, I want to make this into an actual number. There's 2 ways you can go about doing this. You can take 20.25, multiply it by pi, hit equals, and then divide it by 2. You get that. Or you could take 20.25 divided by 2, and then multiply that by pi. In either case, you are going to get, rounded to the nearest tenth, right around 31.8 feet squared. Now, in order to find the total area of the composite figure, since all 3 pieces are shaded in, we just need to add together the 3 areas that we found. So total area, start with that 31.8 plus 27 plus the one that we started with, which was 21.6. Add those 3 together, you get 80.4 feet squared. Make sure you are including your units with your answer. So that's how you find the area of a composite figure when all of the pieces are shaded in. Now you'll run into a situation where not everything is shaded in, like number 2 here. So we've got a rectangle and we've got 2 semicircles on either end. And I've got this piece over here and this piece over here, which represents the semicircles on the left and right, respectively. Now, instead of adding the 2 areas together like we did in example 1, we're going to subtract them this time because not everything is shaded in. Start with the area that's easiest to find. Here it's the rectangle. Now, do you need to copy down the formula for area every single time? No. If you know what you're doing, go for it. So here I'm going to take 33 times 16, and that'll get me my base times height for the rectangle, which is 528 feet squared. There's one area done. Now I got to find the area of the circle. Now here, you may have seen it. This makes a whole circle. These are the pieces from the left and right. So last problem, when we had a semicircle, we took the pi r squared and divided it by 2. Here I've got a whole circle. I'm not going to do that. I can just use the regular old formula for the circle, which is pi r squared. We can find the radius just like from the last one because we know the diameter. Diameter is 16. 16 divided by 2 is 8. 8 is our radius. So pi times 8 squared, which is 64 pi. Again, I want to make this a number. So take 64, multiply it by pi, and you'll get 201.1 feet squared. Now, since not everything is shaded in, we need to subtract what's not shaded in. Here it's the circles. So I got to subtract my area of the circle. I'm going to write it in black like I did last time, and I'm going to label it as total area. Take that 528, subtract 201.1. It's not very good. 1, there we go. And you'll get 326.9 feet squared. And that's the area of the shaded region only. So hopefully those 2 examples are a good starting point for you. I want you now to try number 3 and number 4 when I scroll to them. So make sure you got something to write with. Make sure you got some notebook, paper, or something to write with. Get number 3 copied down and give it a try. Notice how everything is not shaded in. Find the area of the rectangle, find the area of the triangle, and then subtract them. So give it a go. Okay, hopefully you've had enough time to try out number 3 on your own. I'm going to pull down the blind here so that you can see my answer. If you've got questions on this, send me an email after the video lecture here. Okay, I'm going to move on to number 4. Number 4 is the most in-depth out of the 2 that I'm having you try. If you need to use an example, use number 1 as a guide, which is what I said right here. You are going to need to use the Pythagorean theorem for one of the sides of the triangle. How I would approach this: find the area of the rectangle first. Then use the Pythagorean theorem to find the height of the triangle. Once you find the base, to find the base, take 75, subtract 37.5. So hopefully that's enough of a hint for you to try out number 4 on your own. Take a few minutes to do that now. Okay, hopefully you've had enough time to pause the video and take a look at number 4 for yourself. I'm going to remove the blind and show you my work. There's a lot here, so I'm going to scroll down. So again, start with the area of the rectangle. Then you need to find the base and then the height of the triangle. To find the height, that's where you need to use the Pythagorean theorem. Once you find the base and the height, use that to find the area of the triangle. Everything was shaded in this time, so you add the 2 areas together. So that might be in the way. So 1781.25. If they ask you to round to the nearest tenth, 1781.3 meters squared. Again, make sure you're always including your units. So keep an eyeball out on Google Classroom for any other materials that you may need, any other video lectures, any assignments. If you've got questions, send any of the geometry teachers an email. Thank you guys for watching. We will see you in the next video. See you later.